Today we're going to be talking about gas laws, but only one in particular, the ideal gas law. Now, the ideal gas law is located on the chemistry chart right here, the second one in behavior of gases. Now, the ideal gas law is PV equals nRT. What do these symbols stand for? Well, let's find out. The ideal gas law is PV equals nRT. P stands for pressure. Pressure is usually measured in kilopascals, millimeters of mercury, or atmospheres. Volume is usually measured in liters. N stands for number of moles. R is the constant in this equation. And T stands for temperature. Now you have to remember that temperature is always measured in Kelvin. Got it?
Yeah!
So when do you use the ideal gas law? Well, let's look at a sample problem here. A gas is at 34 degrees Celsius. Its pressure is 2.9 atmospheres and has a volume of 12 liters. How many moles of the gas is in the container? Well, let's look here. As we learned earlier, PV equals nRT. The pressure is 2.9 atmospheres. The volume is 12 liters. The N stands for moles, which is what we're looking for in the problem. The R stands for the gas constant, which in the problem we're using atmospheres, so it is 0.0821. And the temperature is 34 degrees Celsius plus 273 because the temperature is measured in Kelvin.
Alright, so now that you know how to set up a problem, let's actually solve this. So 2.9 times 12 is 34.8, which equals N times 0.0821 times 307 Kelvin. Alright, so let's simplify this more. 34.8 equals N times 25.205. Now you just have to divide both of the sides by 25.205, which leaves N to equal 1.38 moles. Alright, so here's another practice problem. At 17 degrees Celsius, a 0.8 mole sample of gas exerts a pressure of 120 kilopascals. What is the volume of the container? Well, the ideal gas law is PV equals nRT.
Yes, we moved.
So the pressure, as you can see, is 120 kilopascals, multiplied by the volume, which is what we're looking for, equals the number of moles, which is, in this case, 0.8, multiplied by the constant, which would be 8.31, since we're working with kilopascals, and the temperature is 17 degrees Celsius, but the temperature should always be in Kelvin, so you have to add 273. So let's simplify this. 120 times the volume equals 0.8 times 8.31, which is the constant, multiplied by 290. So 0.8 times 8.31 times 290 is 1,927.92. Now all you have to do is divide both sides by 120. This leaves you with a volume of 16.07 liters.